Alright, a couple of words about this application. It is used in order to extract data from log files and visualize it as a series of charts and graphs. The main feature of this program is that it continuously extracts data from a specified log file and it puts this data into a database. This information is subsequently processed by the business logic and displayed in the browser as a series of plots, graphs, or charts. As you can see here, the application has the option of configuring the service that does all this. Here I can set the internal log path as well as the access log path. Currently, these are the only two log types on which this program operates. Both logs are Apache Tomcat logs. So I can start the service, and this allows me to view data in real time. Here I can see the HTTP code frequency of an access log. Currently, there are about 500 HTTP 100 entries, and if I click on one of these bars, I can get a more detailed look at these entries. Here I can see what is a server breakdown of the data. I have around 183 code hits from the backup server, 168 from the ground floor server, and 155 from the main server. So all these add up to this main chart right here. Another type of chart, which is statistical in nature, is the pie chart, which actually displays the message frequency of one of the four types of messages that are present in an internal log. So these types of messages are error messages, warn messages, alert messages, and notice messages. If I'm to click on the notice slice, for instance, I can get a detailed breakdown of each server. As I can see here, the main server is responsible for 34% of these notice messages, whereas the backup server is responsible for 32% and the ground floor server for 33%. So basically, that's about it with the pie chart. The timeline chart is more complex because it shows me a real-time visualization of the traffic that is coming to the server. Each circle on the left represents the client with its own IP, and each circle on the right represents the resource on the server. Now, this resource can be either a web page or a script or even a style sheet. The intermediate circles that go from left to right are actually the packets, and each packet has its size, which is represented here by the radius of the circle. So the greater the radius, the larger the size of the packet. The last chart that is visualized in real time is the conveyor chart, which is actually a series of squares, and each column represents a second, whereas each row represents a message type. So the most important messages are the error messages, and they are the only ones that are colored. This is useful in order to determine whether there is a cascade failure or not on the server. If there is one, then we get a high amount of errors in that second, such as this one here where we have 6 errors, or this one where it actually shows the total number of errors that are in the database up to that point. Anyway, now I'm going to stop the service and actually go to the replay data, which is sort of visualization with the property that I can choose the time interval from which I want to view the data. Now, suppose that you've wanted to visualize something in real time, but you were a bit busy with other things, and you overlooked some data. So here I can actually specify the time interval day of a given year and the month, as well as the time, the hour, the minute, the second. Anyway, I'm going to start the replay, and as you can see, the entire data set is visualized as if it were happening in real time. Again, the only difference is that I've specified a custom time interval from which to extract the data. The same thing applies for the conveyor chart, and I can start the replay and all the squares come marching in. So this allows me to analyze something that I've previously overlooked. The last feature that I'm going to present is the report generation feature, which is actually a sort of visualization in which I get to specify custom filters that will actually enable me to extract only a small part of the data set. So I've specified the servers. I can gather data from all 3 servers. I can also select all the HTTP codes, as I'm working on an access log, and I can also check all the parameter types that I want to display, such as get parameters and post parameters. And of course, I can specify the return object size, which is actually the packet size, and of course an IP range. If I'm to click submit, a plot chart is generated, which, as you can see, it is very cluttered. I'm going to filter the data so that I can see better the hit count, and I can actually see that a certain resource has been accessed 4 times within a time interval. So somewhere near 1036 I got 4 hit counts. Now if I want to actually refine this so that I can see the exact second, I'm going to have to specify a narrower time interval. Anyway, I'm going to display this data as a tree chart, and here I can see that the root is colored in red, which is actually the root of the file system of the server. So what you see here is actually data that is stored on the server. So the leaves are actually the pages, the resources that are present on the server, whereas the blue colored nodes are actually the folders. Each number represents the total amount of hits, and each color is actually representative of these hits. So for instance, if the page is accessed frequently, it will have a red color, whereas if it is accessed seldom, it will have a green color. So basically all the popular pages, so to say, are represented in red, whereas all the unpopular pages are represented in green. Anyway, the last chart that I'm going to present is the conveyor chart, which works on internal logs, so logs containing error messages, warn messages, info, or notices. Again, I can select the servers and the message types, so there are errors, warns, alerts, and notices. I can also specify a substring that helps me to filter the class name, because each log line has a class name and a message. So I can display all the classes that start with an A or that contain an A, and all the messages that start with or contain an E. If I click submit, I will get what is a matrix of squares. This matrix represents every log line that satisfies the conditions above. Again, I've highlighted only the errors because they are the only ones that are actually important. And if I click on a square, I get some more information regarding that certain log line. as you can see here, I have the timestamp and the class and a message that offers additional information. So basically, this is my application. It was developed in Java, and the core technology that is behind these visualizations is d3.js, which is actually a JavaScript library, and it is used in order to bind data to documents. And of course, it allowed me to represent data in a visual manner. I've also used jQuery UI and jQuery in order to create a responsive user interface, and of course to help me with the DOM traversal. As I said before, I've used Java, which is the language in which the business logic was written. So basically what we have here is actually a 3-tier architecture in which the presentation is so the presentation layer is displayed on the client in a browser, whereas the business layer is represented as a Java servlet, and of course the persistence layer is represented in a MySQL relational database. So basically this is the layered architecture, and I think that's about it. If I've somehow overlooked some technologies, I will specify them in channel information. So basically that's about it. Now, thank you.